Welcome to another edition of your agricultural biotechnology program, Agribiotech, where the focus is on the significance of biotechnology to agricultural development in Nigeria. I am Lara Afolayo. The Bacillus thuringiensis, or Bt gene, is a common soil bacterium around the world. The Bt bacteria and proteins have been used for several years as biological controls for certain insect pests in farming, particularly the organic food sector. Some approved crops fortified with the Bt gene around the world include the Bt maize and the Bt cotton, which are used and consumed in some developed nations and even South Africa. The Bt gene has now been infused into the cowpea plant to fight the Maruca pod borer, an insect pest that preys upon cowpea plants in many African countries, including Nigeria. This follows previous research by scientists to stop Maruca infestation on cowpea plants, which were unsuccessful. On the program today, we shall be visiting one of the confined field trial sites in Nigeria for the Bt cowpea, which is in Minjibir, Kano, to see the outcome of the Bt cowpea's effectiveness in controlling the Maruca pest. But first, we bring to you our What's New segment. Researchers from the French Agricultural Research Center have discovered that inactivating a gene known as the RECQ4 leads to a threefold increase in recombination in crops such as rice, peas, and tomatoes. Their discovery, published in the journal known as Nature Plants, could speed up plant breeding and development of varieties better suited to specific environmental conditions, including disease resistance and adaptation to climate change. Recombination is a natural mechanism common to all organisms that reproduce sexually. The chromosome mix determines the genetic diversity of species. For instance, to obtain a new tomato variety that is both tasty and pest or disease resistant, breeders cross and breed plants that have the genes involved in taste and resistance. As the impact of climate change continues to grow worldwide, farmers are likely to face new challenges in the form of emerging pests, diseases, lengthy droughts, and floods. Emeritus Professor in Molecular Biology at Penn State University and the former president of the American Association for the Advancement of Science, Nina Fedorov, now suggests a need to take advantage of gene editing and other new breeding techniques. Fedorov was speaking on the potential uses of biotechnology developments for food security and healthcare at a public meeting organized by the U.S. Mission in Uganda. She feels that it is crucial for governments in Africa and other parts of the world to embrace newer technologies that will produce enough food for the growing global population. Crop researchers are hoping to counter these turbulent conditions that need more than the traditional tools available. American professor Frances Arnold and British biochemist Gregory Winter, who are this year's winners of the Nobel Prize in Chemistry, say misguided overreaction to fears about genetically modified food is preventing society from reaping the benefits of the technology. The scientists say countries have been modifying the biological world at the level of DNA for thousands of years, adding that the current regulations on genetically modified food need to be loosened up. They point out the many benefits of genetically modified food, suggesting that genetic modification can make crops more resistant to drought and disease, make food production more environmentally sustainable, and produce enough to feed the world's growing population. An Iowa State University agronomist, Walter Souza, hopes his research will clarify the scientific consensus and spark wider acceptance of biotechnology in Africa. The university done an adjunct assistant professor of agronomy and a co-author of a study says Bt corn could help farmers in Africa combat an emerging pest capable of devastating their crops, even though Africa's adaptation of the technology has been slow. This is against the background of a paper recently published in the academic journal Global Food Security, which analyzed dozens of previous scientific studies on the safety of the BT corn, a genetically modified crop capable of resisting pests. Though anti-genetic modification sentiment is restraining agricultural advancement in the developing world, the study upheld the conclusion that the GM crop is safe for humans and the environment. Welcome back. As I said at the beginning of the program, we shall visit the BT Cowpeas confined field trial site in Minjibir, Kano, where trials on preventing the Maruka pod borer from destroying bean crops have been carried out. The confined field trial site for the BT Cowpea in Minjibir, Kano State. Confined field trials for the BT Cowpea variety have been held here for several years by the Institute for Agricultural Research of the Ahmadu Bello University in Zaria. The BT Cowpea is cowpea infused with the Bacillus thuringiensis gene, a common soil bacteria to fight the Maruka pest or pod borer, which is a major threat to cowpea or beans farming in this part of the world.
We started the experiment far back 9 years back. First of all, we started conducting the experiment in Zaria for 3 years inside a net. We plant and then put a net to cover it because we are going to introduce Maruka on the plant. The net will serve as a check so that the Maruka will not go out and then destroy other people's farm. So we put the experiment inside net and then bombard each plant with Maruka so that we can test the performance of that GM with the non-GM. At that time, we started with 20 larvae per plant. So we did that for 3 years in Zaria, after which we got the result and we decided to expand it to the multi-location, Zamfara, Kano, and Zaria, where we are trying to screen the number of sprays for the GM and non-GM. Our health, if you said you are going to spray, continue to spray with insecticide. Most of our people doesn't know how to even mix the insecticide. They don't have protective wares. So we have a lot of incidents of health problem with those people who are spraying. So we are trying to encourage spraying by producing this GM crop. If you have it, you can spray 1 or 2 times. It reduces the cost of buying the chemicals, and then it can even reduce the health risk.
The managers of this facility say the BT Cowpea and the conventional varieties were planted side by side and the results have been positive.
Actually, I'm telling you confidently, this GM crop is very resistant to Maruka. It resists. Maruka doesn't harm it at all. Because when we put 20 larvae on the plant, you will just see them. Today you put it, tomorrow you just see the larvae. They are just like that, almost dead, half dead. They will not feed on the plant. But if you look at the other one that we are comparing, you will see the Maruka. You will not even see them. They have already bore inside the flowers or pots. They enter and then start feeding on them. But the actual GM, you will see the Maruka just on the either leaves or pod. They're just inactive. So we said that means the Maruka cannot be able to eat the GM crop. Even if they try to suck it, they will not eat it. The BT Cowpea has 3 things which are very important to us. Number 1, if you can be able to plant this GM crop, I'm telling you, what you will harvest, you will be very surprised because disease will not affect it, insect will not affect it. So in terms of increase in yield, definitely you will get at least 80 to 90% yield increase compared to non-GM. And then health-wise, you know, with the non-transgenic, sometimes we spray up to 5 to 6 times, trying to drive away the insect from destroying the cowpea. But with the GM, I'm telling you, if you are able to get 2 sprays, 2 correct sprays at the right time, you will clear away the insects and you will get your cowpea.
Local cowpea farmers in Kano have been part of the activities here and they share their testimonies. They say the BT cowpea has effectively resisted the maruca, while the conventional variety has been badly damaged by the pest.
Is the simple working for them, but only 2 sprays is enough for them. Because the local one, I do the 2 to 4, 5 sprays. So this one is the simple variety for the farmers, because it's the simple working for them.
Gaskiya akwai bambanci tsakanin wannan waken da namu na gida. Saboda shi wannan koda a cikin lokaci aka shuka shi ƙwararre yana saurin yi ba kamar namu na gida ba.
Shi wannan BT cowpea abinda zan ce a kansa yana da matukar kyau saboda yana da ƴaƴa sosai kuma maruka ba ta lalata shi kamar yadda take lalata mana wannan local.
Scientists expect the adoption of the BT cowpea variety in Nigeria to improve nutrition and food security for not less than 8 million farmers and their families. This is in addition to enjoying better health, environment and improved incomes. The variety is also expected to impact the country's gross domestic product more than the conventional cowpea variety. And at this point, we take a quick break. Please stay with us.
Did you know that genetically modified organisms, GMOs, are safe and do not pose any risk, hazard or danger to human, animal and the environment? Neither do they cause cancer, infertility, sterility, tumor or any adversity. There is safe use of GMO drugs like insulin, vaccine, rapid diagnostic test kits for malaria, HIV, hepatitis and so on. The safety of GMOs is certified by the World Health Organization, WHO, Food and Agricultural Organization, FAO, European Food Safety Authority, EFSA, the National Academies of Science globally, the Royal Society, UK, and over 110 prize Nobel laureates. GMOs are safe, effective, and certified by MBMA in Nigeria.
This message is brought to you by the Nigeria chapter of the Open Forum on Agricultural Biotechnology, OFAB, supported by the National Biotechnology Development Agency, NABDA.
The cowpea trial site we saw earlier on the program is being managed by the Ahmadu Bello University's Institute for Agricultural Research. And next, we join the executive director of that institute, Ibrahim Abubakar, as he brings us up to speed on the BT cowpea's research in Nigeria.
Research on BT cowpea actually started in 2009, and it is funded by USAID in collaboration with African Agricultural AATF, African Agricultural Technology Foundation, And we have done trials on confined fields. That means restricted areas so that the gene does not contaminate our other cowpea varieties in the environment. And after that, we have gone multilocational, where we started the trials in Zamfara, Kaduna and Kano states. In addition to that, we have tested them in farmers' fields, what is called on-farm trials. Now we have collected all this data. Now what is left, which is outstanding, is to make a dossier to the National Biosafety Management Agency about the BT genes and the varieties we are about to release. The National Biosafety Management Agency is expected within 270 days to communicate to us the acceptance or rejection of our dossier. After that, we'll then make further progress by going to the National Variety Release Committee. We submit our data, both the on-station trials, the multilocational trials, and the on-farm trials. And the committee will look at the data and see if there are benefits actually in releasing the variety. If the variety proved to be superior over our existing varieties, then the varieties will be accepted by that national committee, which will then give us the go-ahead to multiply and release the varieties to seed companies and farmers. So actually, as it is now, we only have 2 hurdles ahead of us. And these hurdles are actually good for the country because it is taking a responsibility for the varieties. By the time we submit a dossier to the National Biosafety Management Agency and they accept the dossier, that means they have given us the go-ahead, taking all safety measures into consideration to commercialize the variety. Then by going to the National Variety Committee, which is a committee of experts drawn from various crop disciplines in this country, across research institutes, across policymakers, across extension and seed organizations. By the time this committee gives us the go-ahead to release the variety, it's like taking responsibility. That means at this stage, it has become a national variety. It has come out of research. So the responsibility now is for Nigeria. So that is why the way things are coordinated this way, it is good for the research, it is good for the country, and it is good also for the policy and regulators of variety and seed in Nigeria. I think the impression of the Institute about this variety is the fact that, one, the variety has superior yield over the existing cowpea varieties of the Institute, over the existing improved cowpea varieties of the Institute. And then secondly, because of the resistance conferred on the variety by the genes, they resist the commonest insect pest of cowpea, which is maruca. And because of this resistance of maruca variety, farmers will have to spray less. And when farmers spray less, it means production of cowpea will be economical, because spraying is money. You pay for the herbicides, chemicals, you pay for the labor in spraying. So if instead of spraying 6 times in the crop cycle of cowpea, you now spray only 2 times, that means a lot of savings to to the farmer. And it also means that the income of the farmer will be increased. So the impression generally is, one, the release of this variety is likely to improve food security, because it will mean more farmers will be engaged in cowpea production, and it will mean increasing the production of cowpea for the benefit of the nation. And then secondly, it will improve the income of farm household. Farmers who grow this, who are likely to grow these varieties, are definitely going to have more income, resulting from less cost of production and increased yield. And this will be more profitable to the farmers, and many of them will laugh actually to their banks. Yes, I have heard a lot about noise makers actually. Let me say noise makers, who said genetically modified organisms have harmful effects on human health. But to date, nobody has convinced the scientific community, I have not seen any, that definitely GMO causes this disease or that disease, not speculation. You could say GMO is speculated to cause cancer. What is the speculation? What is the basis of the speculation? Come up with concrete evidence that this is what GMO causes in human health. And if you convince us with concrete evidences, we are for humanity. Every agricultural scientist works for humanity. We work to produce crop either through conventional means or through biotechnology. And if you say production of crops through biotechnology is harmful to human health, why not? We'll stop. We are for progress of humanity. Anything that is anti-progress to humanity is anti-progress to science, and is anti-progress to agricultural scientists. We will not go for it. And as for the environment, similarly, I have not seen, we try as scientists as much as possible, because most of the argument about environment is pollution of our existing crops. And it is gladdening to inform you that introduction of GMO will not pollute the existing crop varieties, because varieties of crop are not the custodians of farmers. We scientists are the custodians of varieties, not farmers. Farmers are not the custodians of varieties, because eventually the varieties that are released by IAR are jealously guarded by IAR, to such an extent that if you come tomorrow and say you want Sampi 7, for example, we have pure Sampi 7 always available for us to generate and multiply. So introduction of BT cowpea will not in any way pollute the existing varieties. For example, apart from our effort in preserving our varieties, we also have international gene banks where all these genetic materials, all the varieties grown and released in the world are put in a gene bank, for example, in IITA and other research centers where you can always fall back to. So to say that if you, there is always the fear that if we introduce a new material, it's likely to overtake or supersede the existing materials in such a way that the existing material will disappear. No, it will not disappear, because we try to preserve this. And IAR is, apart from the routine variety maintenance, where after every 2 years we grow them in the field to maintain them. We are almost completing our own gene bank, where varieties will be permanently kept for a very long time without losing their viability and preserving the genetic purity of such varieties. You see, the good thing about it all is we are not doing this alone. Like I said, apart from the Research Institute working hard assiduously to produce this product, there are regulatory agencies also that they are working hard day and night to ensure that whatever we produce are not harmful to the society. And BT gene generally are not particularly very different. The BT gene in maize is not very different from the BT gene in cowpea. So if BT maize can be grown successfully and consumed successfully in America, in South Africa, and several other countries, and even the BT cotton, we consume it indirectly, even if in some instances we even consume it directly, because cotton seed is used in producing oil, and we use this oil as cooking oil, so it's direct consumption. So since BT cotton, BT maize are consumed without any harmful effect, and I believe there are mechanisms developed by the National Biosafety Management Agency to ensure that to do all the toxicity studies and what have you. And in the dossier we are submitting to the National Biosafety Management Agency, there are studies on toxicity of the cowpea grains and so on. So it is that agency that will confirm whether what we have submitted in that dossier is correct or not. If they found it not to be correct, they will definitely reject the dossier and it will not be released to the consumer.
And from our feedback segment, we come to the end of today's program. Send your emails to agribiotech1@yahoo.com. Send us tweets at agribiotech13 or post comments on the Facebook page Agribiotech on TVC. I am Lara Folayo. See you same time next week.